you may remember this diagram from our previous video in which we looked at a maze. This maze remains the exact same, however we've added a single hook which we would like to move from this square to this square. Now, just like the other activity, I strongly encourage that you look at the problem and you break down each separate movement that occurs, so it's very easy for us to map into the actual code. So, in order for us to get to the position to actually pick up the hook, we would once again go forward, and all we need to do is use an up action to pick up the hook, right? We need to use our medium motor to move upwards in order to pick up the hook. So this would also be the second part of the program. And then we need to actually turn in order to get into a position to move. So we can also imagine a turn that would occur in order to get to that pivot point. Then we would simply go forward, and in order for us to lower the hook, we would release the medium motor back to the position that it was, giving us 1, 2, 3, 4, 5 steps. So, moving on to the code that we built in the previous activity, the movement of, or the navigation through the maze will remain the same, which means that the majority of our code will also remain the same. This is why I'd like to remind you that when we do these exercises, I strongly encourage you to save code because it allows us to carry over the code, and it is also very good practice to store all your code because when you go back to remember things and the way you did them, you can often access that code. Now let's look at the specific situation. I've made these blocks smaller. These are just the same blocks that I showed you in the previous paper. I've simply enlarged the medium motor blocks that would be used to actually pick up the hook and move them down. Notice that I placed each block after the steps that I drew on the diagram. I placed this block after the move forward block because I wanted to pick up the hook right after I move forward. And I made this the last block because the last step that I wanted to make in the entire process was to drop the hook. So in order for us to change the amount of time we would like the medium motor to move, we once again will choose the seconds as our units. We will change our power to be 50. I chose 50 because once again I think that when we make rotations, making low power rotations is good because it allows us for more accuracy. And I chose the seconds to be 2. Now the way we determined seconds to be 2 was just by simple testing, as we would encourage you to do so when you build your own robots as well. However, this number should work just fine for you. And then we have our break at the end. So now let's take a look at the next motor block, which is going to be lowering the hook itself back towards the ground. So once again, we would like it to be in seconds. And this time, we're still wanting a magnitude of 50. However, we need to notice that since we're lowering the motor, or we're lowering the arm of the motor, we need to make the value negative. This is important because that is doing the exact same motion that we did earlier, however, just in the opposite direction. And we will pick 2 once again to return it to its original place, and we will continue breaking. So I've pulled up the code from the activity that we did on the maze problem, and it should look the exact same. And all I need to do is move over the 2 medium blocks over, the medium motor blocks over, into the places that we decided on the piece of paper. And all I need to do is make sure that the values that we determined check out. I need to make sure that the port D matches up. I need to make sure that I'm working in seconds. and change the power to be 50 and the amount of time to be 2 and end with a stop. And I can do the exact same thing for the last one, except just make sure it is negative. We can simply export the code and check out how it runs.